So some bonus material for you for section 8.1. Some of the harder problems would include something like this. Now, what most people probably wouldn't like about a problem like this is that it's got fractions. And my suggestion is that when you have something that has fractions, you just get rid of them. Get rid of them right away. Now, the way to get rid of the fractions is this. You're going to multiply both sides by the lowest common denominator. So in this case, the lowest common denominator would be what? 3. Good. So I'll multiply this side by 3 over 1 and this side by 3 over 1. You don't have to write 3 over 1. I do that because, you know, it lines things up and it gives you something to cancel. So, for instance, the 3 here and the 3 here, cancel. 3 here and the 3 here, cancel. And so that makes this a much nicer problem. What we're left with is the 4 times y plus 6 equals 59 minus y. So we got rid of the denominators, which is a good thing. Now, let's distribute it on the left-hand side. That's going to be 4y plus 24 equals 59 minus y. If you notice, I've got y on both sides, right? I need to get the y variable on just one side. Now, who's paying attention? Remember Jeff's rule for which side you want to put this on, the left-hand side or the right-hand side? Yeah, we want to put it on the left-hand side. So you want to put it on the side with the larger coefficient. That'd be this side. So I'll add y to both sides. That cancels, leaves me with a 59. Over here, I've got 5y plus 24. Okay, so I got my variable on one side. Let's get everything else to the other side. So 5y equals, well, if I subtract 24, that's going to be 35. Divide both sides by y. What does y equal? 7. Nice, thank you. Now, here's something cool that you can do with your graphing calculators. And if you're curious about it, I can show you how to do it. I've got this equation typed in, but I didn't have the correct value of x in it. So I got 0 right, or 0%. But what if I take 7, which is the correct answer, and store it in x? Now I wrote my equation with x as opposed to y just out of convenience. But let me go back and retype this equation now and see what happens if I'm checking the right value. Now if I got it right, I should get 100%, right? 100% as a decimal is a 1, so bam. Nice. It tells you got it right. So that's a good thing. Now, if you don't have a fancy graphing calculator like this, you can check it by putting it back into the original problem. That'd be this one up here, and making sure that it works. So 7 plus 6 would be 13, times 4 would be 52 over 3. If I put in a 7 here, 59 minus 7 is 52, again over 3. So both of those things would match. But, you know, if you can use technology, hey, that's great. How's that first one looking? Okay there? All right, good. Let's try some more here. Let's see. How come this isn't showing up? Come on, come on. Where did you go? All right, this isn't good. That one's there. Here it is. For the second one, I'm going to kind of skip that. I'll talk through it a little bit. What you would do here is you'd multiply by 10, distribute that 10, and distribute the negative sign to both of these terms here. So that way you get rid of the parentheses, and then you can start moving things around, combining like terms. But let me move down to the inequality one. And I chose that one in particular because it has a negative in there. And I want to remind you how to work with those negatives. So call this example B. That's going to be negative 12x minus 4 is less than or equal to 20. So let's change up the camera over here. Now, probably a couple ways you could solve this, but most people, I would think, would just say, all right, well, I'll start out by adding 4 to both sides. And that's a good way to start. Negative 12x is less than or equal to 24. But the reason I chose this one is because I want to remind you about working with inequalities, and in particular, when you've got a negative. to solve this, negative 12x is less than or equal to 24, I need to divide both sides by negative 12. What special thing is going to happen when I divide by a negative?
It's going to flip your sign.
Yeah, excellent. You're going to flip that sign. So that's going to be x is greater than or equal to negative 2. Now I'm going to give you a couple other things here because sometimes you're going to be asked for this on Webassign. The first one is how to graph this. Let's just put the one number that we need, which is negative 2. There's a couple styles you can use here. My style is to put a solid dot here, and then I want everything greater than negative 2, so that would be to the right. Less than would be to the left. If I had, say, just x is greater than negative 2, then the difference here would I'd be using a hollow dot. Now, some people use brackets and parentheses here. That's okay. The brackets come from our bracket notation or our interval notation. The interval notation from this would be negative 2 to infinity. So you're including the negative 2 by using a bracket here. Infinity and negative infinity always get a parenthesis. In contrast, up here, if I had x is greater than 2, I don't want to include the negative 2. So I do that with a parenthesis. So be aware that Webassign is going to bust you if you use a parenthesis when you're supposed to use a bracket or vice versa. So just kind of heads up on that. Okay with example B? Doing good on that one? All right, let's keep going. So another inequality. Let's solve this one. And again, I'm trying to choose some of the ones that are a little bit trickier and harder simply because I want to give you practice on some of the more challenging ones as opposed to just all the easier ones. So let's go back to Jeff's rule here. I've got a negative 8 and a negative 6. What side do I want to put the variable on, the left-hand side or the right-hand side? Negative 6. Yeah, the right-hand side. Good. Because negative 6 is bigger than negative 8. So I want to move this over here. And I do that by adding the opposite. 8y, 8y. And I get 4 is greater than 2y minus 10. So I got my variable on one side. Let's get the constant on the other side. So we'll add 10 to both sides here. That gives me 14 is greater than 2y. Divide both sides by 2. I get 7 is greater than y. Now, I don't know if you're comfortable with this or not, but this is a little bit opposite of what we're typically used to. I know I'm going to have a 7 here on my graph, and because this is a greater than or not a greater than or equal to or less than or equal to, it's going to be a hollow dot. But which way does the inequality run? Am I going to draw the arrow to the right or to the left? All right, to the left. Good job. It is to the left because I want numbers that are smaller than this. But here's a little trick that's kind of convenient. If I take this and I just flip it all the way around, this is equivalent to y is less than 7. Notice that the inequality is pointing in the same kind of way. It is the smaller end is at the y, the larger end is at the 7. So these are equivalent. The nice thing is if you have your variable on the left-hand side, that inequality points in the direction you're going to draw your graph. Less than, oh, goes like that. Greater than, oh, goes to the right. So this inequality points in the direction that you're going to draw your graph as long as the variable's on the left-hand side. So a nice little trick if you can pick it up. If not, don't worry about it. Just try and think through which way you're going to draw this. Okay, last one here. Going back to equations. So this one's kind of nested. And I'm going to help you work through this one. So 12 plus 3 times x minus 4 equals, minus 18. And then equals 2 times 5 minus 4 times 6 minus x. So kind of a lot going on here. Let me click back over to my screen here so you can see what I wrote down. If you remember that old acronym from some of your other math classes, PEMDAS. All right, does anyone remember what that stands for? Wow, excellent. Bonus points here for my crowd. Yeah, parentheses, exponents, multiplication, division, addition, subtraction. Please excuse my dear Aunt Sally. I actually did have a student one time who had an Aunt Sally. I never got any feedback about what Aunt Sally felt about being part of this acronym, but that's okay. So we want to start with the innermost parentheses. That means right here, I'm going to distribute that -4 to both of those terms. And over here, well, I might as well get busy on the left-hand side as well. I can distribute the 3 to both terms. So 12 plus 3x minus 12 minus 18 equals 2 times 5 minus 24 plus 4x. Now inside both of these, or on both sides, I've got some simplification I can do. For instance, I've got a 12, and a -18. Those are all like terms that I can simplify together. And on the right-hand side, well, not as much, but those can simplify. Now there's something nice about the left-hand side. Does anyone see it in terms of simplification? Yeah, the 12s just cancel each other out. Might as well do it that way. So good eye on that one. That leaves me with 3x minus 18 equals 2. And before I distribute, I'm going to simplify in here. 5 minus 24 is -19. And bam. Let's keep going. I'll finish by distributing on the right-hand side. And it looks like it's going to work out nice and even, which is good. Let's get the variables on one side. The bigger coefficient is on the right-hand side, so I'll subtract 3x from both sides. That leaves me with -18 equals -38 plus 5x. I've got my variable on one side, get the constants on the other side. So add 38 to both sides. -18 and 38 gives me 20. And if x equals, or 5x equals 20, what does x equal? 4. Nice. Nice. All right. How are you guys with that one? Pretty good? All right. Excellent. So that'll kind of conclude our little bonus work, and I'll let you get busy on the homework. Any other questions or thoughts? No? Okay. Good luck.